Right, so in this module, we're going to be talking about a really important part of programming and our first step along the way of being able to write some very interesting programs, and it's branching. So you might have started to get the idea already that a straight line program, a program that does the same exact thing every single time you run it. Maybe it asks for some input from the user, so the output or the printout might be a little bit different. But basically, a program that does the same sequence of steps each time is pretty boring and actually can't really do a lot of interesting things and a lot of things that we're going to want to do with the program. Basically, if you don't use branching and you don't use what we're seeing today, your program is essentially a fast and maybe a little bit more flexible calculator. It's not really a program designed to react to the conditions of user input or of any other aspect of the system. So what is branching? Branching is a set code that allows us to start out executing a sequence of instructions and then write a test. All right, a test for a particular condition. So we'll call it a Boolean expression over here, but what you can really think about this is, is A equal B? Is 5 less than X, right? So it's a simple question. It's a test that's going to result in a true or false value. Remember, Booleans are true and false values. So we're going to have a test to say, okay, is this true or is this false? If it's true, I'm going to execute a block of code. If it's false, I'm going to execute a different block of code. And when I'm done with that if statement, I'm going to go down and proceed executing the rest of the code in my program. So it's a branch in that after the test, we're going to follow either one side of this or the other. Now looking at actual, so looking at the actual code and how this lines up, before the if statement, you can have any amount of Python code here. Doesn't make a difference how much is there. You don't even need to have any at all. Typically you would. The test is going to be written using the following syntax. We're going to have a keyword if followed by some sort of a Boolean expression. And we haven't completely defined what that means yet, but again, it might be something like if A less than B, if A with the arrow symbol B, followed by a colon, and then a whole bunch of code. And you can have one line of code, you can have 1,000 lines of code if you want. It doesn't matter how much code is in here. Any code that's indented underneath this if statement is going to be executed if this Boolean expression is true, right? So the true block is really corresponding to what's right here. The else block, right? So you can think of else as sort of like otherwise. So if some condition here is true, execute this code. Otherwise, execute another block of code. Do something else. Right? And this could be very trivial, right? This could be a set of print statements if it's true and a set of different print statements if it's false, or if this can be very, very involved. Once we're done with that else clause, right? And again, all the code that's indented after the else will belong right to that block. Once we're done with it, we'll break back out to be aligned with the if and else statement out here and the initial code out here. And then this will be code that regardless of whether this Boolean expression was true or false, will execute, right? So regardless of what happens with this if statement, this code executes. At this point, we're either going to execute this or this, and then once we're done, both sides of that will end up executing some more code. Again, syntax. This is an area where you're going to start to make a few more errors. There's going to be a few more special symbols that you need to be aware of. First off, that after the if and the else clause, so the if clause always takes a Boolean expression, the else clause does not. It's just a keyword. But after both, we have a colon. The colon is representing or telling you, okay, here's the following code block. This white space, this empty space here, it's extremely important that you have that. In most programming languages, if you're coming from C++ or Java, there's other ways of associating blocks of code, but generally white space or tabs or spaces, they don't mean anything in most of those languages. That is not the case in Python. So I generally, when I'm writing Python code, I use tabs. Some people use two spaces. If you're going to use the space bar, use the same amount of space on each block. But if you want to just use the tab, that's probably easiest. that tab actually has a syntactical meaning. If you leave that tab out and you write a block of code that lines up right with this if statement, you'll get an error. That's illegal. Importantly, if you write some lines of code and then forget to indent them, they won't be associated with the else clause anymore. They'll be part of this some more code part. All right, so the indentation is required. It is something that is telling Python that the code that's indented, it belongs to these clauses, these if clauses, this else clause. Later we'll see else if, and we'll see for loops and all that kind of stuff as well. And again, the same thing will hold. Indentation matters. You don't always need the else clause, right? If you want to do something if A is less than B, and here you're seeing a real actual example of this, right? So I might have a variable A, a variable B, and if A is less than B, I want to print out A is less, and maybe my program doesn't really need to do anything for the other case, and maybe down here, without the indentation, I might have something else. In this case, again, whether or not A is less than B, I'm still going to print this. All right, this is not associated with the if statement because it's not indented, and there's no else clause. All right, if A is less than B, I'll print this, and then I'll print this. If A is equal to B or if A is greater than B, I'll skip this part and I'll just print I'm done. All right, no need to put an else clause if you don't have anything that's specific to that otherwise case, that's specific if this is false. You cannot have an else clause without an if first. Right? Think of the if as the beginning of a sentence. The else is really an otherwise. So you can walk up to somebody and say, okay, well, if it's raining today, do this. Otherwise, do something else. But you can't walk up to somebody and say, otherwise, do this. Right? You have to start the conversation with that if, and it's the same thing in programming. So it doesn't make any sense to have some code that's not indented, it's not part of an if statement, and then just kind of have an else floating out here. That won't work. That'll give you a compiler error or syntax error when you try to run that code. Where that'll give you an actual error and that will not let your program continue to run, there's other mistakes that we can make with branches. And so probably, I think one of the most important rules to consider when you're writing code. Right now, you're just trying to get a hold of the syntax. You're trying to make sure that your programs actually run without crashing, that they actually print out the right data. But you'll get past that pretty quickly. And one of the things that you're going to hopefully start to realize that there's code there's good code and there's bad code. And there's some bad code that actually produces the desired output but it really isn't written very well. Just like there's a good, you might look at two essays and one of them, they might be talking about the same topic, they might have all the same information, but one of them's really well written and the other one just isn't. And there's a difference, right? And programs work the same way. And one of the most important and very simple rules in programming in trying to develop a code that's actually of high quality is don't repeat yourself. All right, it's called, the acronym is DRY. All right, and it's something that you want to keep in mind as much as you can. If I look at the program down here, I'm saying if A is less than B, I'm printing 3 things, and otherwise I'm printing another 3 things. But if you notice what's highlighted in yellow, before I print A is less than B or A is greater than B, in both circumstances, I print this is a great program. This print statement is not unique to the if clause or the else clause. I then have some statements that are unique, right? That actually belongs in the else clause. And then I have a repeated statement, goodbye, have a nice day, goodbye now, have a nice day. In both cases, I've repeated myself in the if clause and in the else clause at the end. Right? This is a classic example. This is something that when you're just starting out programming, I see a lot of people make this mistake, and it's sort of a telltale sign that you're not quite, you haven't really learned completely how to write good code yet. You do not want to do this. It'll print out the exact same thing as this following code, but this following code is far better. All right, because we now have not repeated a whole bunch of code over and over again. We can go and change this sentence in one place and have both conditions print out the same way. So here I've taken the code that was before both of those print statements and I've moved it up out of the if clause. So no matter what, I'm printing this is a great program first, as opposed to before printing it no matter what, but actually duplicating that code. Rule of thumb is to only have code inside an if clause or else clause if it only executes, or if it should only execute in that condition. If it should execute in multiple conditions, it probably doesn't belong in the else clause or the if clause. It probably belongs outside of the if statement. So here we see these if statements only having exactly what's unique to those given conditions. And then finally, flip back again, we had this goodbye now repeated after the print statement. So I've moved that out and I've done that no matter what. The output of this program will be exactly identical as the first one. This one is written far better. We've talked about Boolean expressions now. I showed you the simple one, a less than b. We have all the standard relational operators available to us in Python. So less than or equal to. By the way, the order matters of these symbols, so you cannot write it this way or this way. You have to do the less than and equal to in that direction. You also cannot have a space in between that would indicate a separate operator. Right, so the less than or equal to, the greater than or equal to, you've seen the double equal signs and the not equal sign as well. They're compound operators. So any of those relational operators plus logical operators and an or can also be used to construct fairly complicated Boolean expressions. The rule is that inside the if statement, it has to be a Boolean expression. It has to evaluate to true or false, but it can be of arbitrary complexity. All right, so here we've got a kind of a complicated looking if statement. If A is less than B and A is greater than C, or D is less than E. And I might write this a little bit different to make this a little bit more readable, but let's try to dissect this. It turns out that the or operator is a relatively low precedence value as opposed to the and operator. So if we kind of look at this, we would be really saying is if A is less than B and A is greater than C at the same time, right? So let's say A is 5. If B is 10 and C is 1, right? The AND operator is the highest precedence. So if both of those two conditions are true, or D is less than E, the entire statement will be true. If this is false and that's false, then the entire statement will be false and will drop into the else clause. You want to make sure that you review your Boolean logic. Talked about in the textbook as well. And or operations are very, very common. You want to make sure that you're very comfortable using them in a variety of different ways. All of these relational operators and logical operators fall into an overall operator precedence list. And so if you think about what does operator precedence mean? In standard arithmetic, we've got multiplication, we've got division or addition and subtraction. And I think we all, of course, know exactly how to do that. So if we've got, let me see if I can sketch this. If we've got something like 3 plus 4, let me move the size down here, times 2, we sort of implicitly know that the multiplication is of higher precedence, right? And so we're going to get 8, and then we can evaluate this to be 11, right? Well, so when we have A less than B and A greater than C, or D less than E, we have the same precedence rules and the way we evaluate this expression works exactly the same way. If we consult that table, if we go down this precedence chain, we can see that the relational operators are of higher precedence than the logical operators down here. And again, if we had any mathematics, we would have done that first. Right? So we can actually evaluate these less thans and greater thans first. So let me just And let me just assign some values. All right, so A is equal to 5, B is equal to 3, C is equal to 7, D is equal to 10, and E is equal to 7. Okay, so if we want to follow precedence rules with this, the first things we're going to do is the relational operators. A less than B. All right, so if we do A is less than B, that's false. A greater than C, that's false. And D less than E. This is kind of a bad example, I guess, but that's false. All right, so those are the first things we're going to do. We're going to still have the and in the or. Then if we go back to our precedence rules table, we can see that and is of higher precedence than or. So we're going to evaluate this next. And false is just false. And now we're left with false or false. And again, that's false as well. So precedence rules are very important in terms of evaluating logical operators and relational operators. And you want to make sure that, if you've seen this kind of stuff before, if you've learned another programming language, that might be pretty easy. If you haven't seen this before, this is something that you want to practice. You want to make sure that you're very, very comfortable with creating expressions using relational and logical operators. Things are not just yes and no, right? So we're not restricted to just having binary operators. We can have several options, or maybe we call these conditions. So we might say, all right, well, if A is less than B, print out some message. Otherwise, now check to see whether B is less than C. All right, so we have a secondary check here. It's a very common structure in programming. Lots of times, if one thing's not true, then we're going to have to go check some other conditions to determine exactly what to do. That's much easier to write using the else if clause. Right? So elif stands for else if. And the way I'd say it out loud is sort of like if A is less than B, print condition 1. Otherwise, if B is less than C, print condition 2. And then otherwise, without any test, meaning basically if all else fails, if all other conditions prove false, then print out condition 3. So the elif command, and again, it's not, if you're coming from another language, a lot of languages write it like this. The elif command in Python is all one word, and it works very similarly as the if clause. When using else if, right, make sure that you understand the order in which expressions actually get evaluated. When you have a clause like this, the if clause, the Boolean expression associated with the if, is always tested. If that Boolean expression, so if this becomes true, everything else is skipped. All of this code will be skipped and nothing will be checked. If this is false, then we'll move to the next Boolean expression. We'll say else if this is true. And if that's true, all of the rest will be skipped. And we'll keep moving down. As soon as we find one of these expressions that's true, we'll execute the code block and we'll skip all of the rest of the code. If all of these else if clauses and the initial if clause is false, then finally we'll drop down to this else block. Right? So the order really matters in the way you actually test these things. Sort of your flexibility in how you can have all these options. This is all one chunk of code, right? This is all kind of an associated block of code. You've got an if statement, which is required. It always starts a branch. You've got a series of else clauses, or else if clauses. These are all optional. If you don't have multiple conditions, you certainly don't need an else if. So you might have 0 of these, or you could have 1, or you could have many. And then you can end. But once you have the else clause, that's the end of the branch. You can end with an else, right? Without an if, right? This code block is going to execute if none of these, it captures all the rest of the possibilities. It again is optional. If you don't have something to do if none of the conditions hold, then you don't need an else clause, right? But you can only have at most one, and it always appears at the end, right? So it's always the if statement followed by any number of else ifs or 0. and it always ends with an else or just with nothing. All right, it can end with an else if with nothing followed by it as well. There are some subtle mistakes that you can make. So the following code is perfectly reasonable. It's perfectly fine Python code. This if expression, however, is not connected to this. There are independent tests. You can have a series of if clauses in your program. You can have as many if statements as you want. You might have some code here, or you might not. But the bottom line is if this is true or if this is false, no matter what, we're still going to check this if statement next. All right, so the ifs are independent. All right, and then of course this is all one block of code. Right, that's all one branching sequence. Okay, so couple of words about this module. Um, First off, read the textbook. Make sure that you go through the textbook, you look at these slides very carefully. If you are new to programming, this is a pretty typical spot where things start to feel a lot harder. They seem to be a lot more challenging. You've had a lot of syntax thrown at you, and you have to start to think a little bit more in a logical manner. First thing that you want to make sure that you get is Boolean algebra, Boolean expressions, the ands, the ors, the relational operators. I also really urge you to do the programming exercises associated with this module. So this is the first module that I've got a series of exercise problems for you to do. Some of them are loosely connected to what's in the textbook as well. You should do them yourself. You should work at them. They're designed, the first time if you've never programmed them before, they are going to be a little bit difficult. They're going to take you some time to figure out. Don't get discouraged with that. That will, improve over time. You'll get very good at this kind of stuff. But try to push through struggling. You're going to learn a lot by struggling through these problems. Don't just go right to my solutions. So I've posted videos of me solving the programming examples. I've posted code. I really strongly advise you to try to really spend a lot of time doing it yourself before you revert to looking at the solutions, because you're going to learn a lot more by doing it yourself than actually watching my solutions. So please try to keep up with those programming assignments, and we're going to start to look at some other sort of like branching, some other structures called loops coming up next.